Air pollution is an issue of public concern in Hong Kong. Air pollutants are often found in fairly high concentrations in urban areas, and this could pose a threat to public health. There are several sources of air pollution in Hong Kong. They include exhaust fumes from road vehicles, waste gases and particles from power plants that are created from the combustion of petroleum or coal, exhaust air from factories, also caused by fuel combustion, and excessive oil fumes from commercial kitchens.
We can test for pollutants in the air with experiments. To get a rough idea of how much pollutant there is in the air, we can use a portable digital calibrator like this. If we want to test how much carbon monoxide this engine emits while burning gasoline, we place the sensor near the exhaust outlet. The calibrator shows us the amount of carbon monoxide in the exhaust fumes. We can also use gas detector tubes to test for air pollutants. Different tubes are used to test for different gases. Different chemicals are placed in the tubes. Each reacts with different gases by changing colour. This tube, for example, tests for carbon monoxide. If we pass exhaust fumes from the engine into it, the yellow chemical inside turns black, indicating the presence of carbon monoxide. We can use chemical methods to produce other pollutant gases for testing. The gas being released here is nitrogen dioxide. If we pass the nitrogen dioxide into the tube, the white chemical inside turns yellow. If we're testing for sulfur dioxide, the blue chemical inside this detector tube turns yellow in its presence. There are several major sources of gaseous pollutants. Sulfur dioxide is produced when mineral fuels are burned or when substances containing sulfur are processed in power plants or boilers. It's also present in the exhaust emissions of road vehicles. Nitrogen oxides are oxides of nitrogen. They include nitrogen monoxide and nitrogen dioxide. They're produced during high-temperature combustion in power generators and by running car engines. Carbon monoxide is produced when carbon or fuel is not burned completely. It is also produced by some industrial procedures. Vehicle exhaust fumes are major sources of carbon monoxide. Ozone is another kind of pollutant gas, but this one isn't produced by industrial procedures and isn't found in vehicles' exhaust fumes. It's formed when nitrogen oxides react with certain volatile organic compounds under the ultraviolet rays of sunlight. As well as pollutant gases, the air also contains minute solid pollutants. We call these suspended particulates. They come from diesel car engines, construction works and certain industrial procedures. Some occur in nature. Suspended particulates contain various chemical particles, inorganic fibers, minute particles of metals like lead, and various organic matters. If we use a special filter paper to filter the exhaust fumes from cars, we can collect suspended particulates from those fumes. By comparing the weight of the filter paper before and after the experiment, we can get a rough idea of the weight of the suspended particulates in the air sample. By using an X-ray screen machine like this, we can analyze the different kinds of suspended particulates. The different curves on the screen represent the different types of suspended particulates. These experiments show that there are many substances in the air that cause air pollution.
The effects of air pollution on our health depend on various factors. They include our individual health condition, for example, whether we have asthma or rhinitis, the types of toxic substance, whether, for example, it's carbon monoxide or sulfur dioxide, the dosage of substances we receive, and environmental factors such as temperature, humidity, light and pressure, etc. Sulfur dioxide is a colorless gas. It is odorless at low concentrations and pungent at high concentrations. Exposure to an environment with a high concentration of sulfur dioxide can damage the respiratory system. In people suffering from bronchial allergy or bronchitis, it can lead to shortness of breath, difficulty in breathing, or coughing. Nitrogen monoxide reacts with hemoglobin in the blood to form a stable compound, which obstructs the transportation of oxygen to body parts by red blood cells. Nitrogen dioxide can also irritate the lungs and lower the respiratory system's resistance to infection, rendering the body prone to influenza. The effect is particularly strong in children. If serious enough, it can obstruct lung growth. Carbon monoxide is colorless and odorless. Like nitrogen monoxide, carbon monoxide can combine with hemoglobin to obstruct the transportation of oxygen around the body. Long-term exposure to carbon monoxide can lead to considerable impairment, including damage to learning and working ability, as well as to brain function. Exposure to high concentrations of carbon monoxide can even be fatal. Ozone toxicity is cumulative. The higher the concentration and the more vigorous the activity during contact, the greater its effect will be. Ozone irritates the mucous linings of the nose, throat, and bronchi. It will attack the respiratory system and damage pulmonary function. When suspended particulates enter our lungs, they are collected deep inside. This causes harm to our health, including respiratory problems and even long-term damage to lung tissue.
The government and the public have long wanted to improve air quality. We need a set of standards for acceptable air quality so we can measure whether it is safe for public health. Based on the concentration of pollutants, length of contact and possible effects on public health, EPD has laid down a set of air quality objectives, AQOs, which help measure air quality and ascertain if it is within acceptable standards. To keep the public informed of the air quality situation at all times, the EPD delivers public announcements of the day's air pollution index every hour. It also forecasts the API for the following day. The EPD has set up more than 10 fixed monitoring stations to monitor air quality throughout the SAR. This is a high-volume sampler, which is used to measure the concentration of suspended particulates in the air. These apparatuses measure the concentration of pollutant gases, including sulfur dioxide, nitrogen oxides, and ozone. The Air Pollution Index, API, is derived from the data obtained from the monitoring stations, which includes concentrations of suspended particulates, sulfur dioxide, carbon monoxide, ozone and nitrogen dioxide. API ranges from 0 to 500. When the index is below 100, it means that the air pollution for this hour, or over a 24-hour period, is at an acceptable level. Usually Hong Kong's API is below 100. The lower the index, the less polluted the air. However, when the index exceeds 100, people suffering from heart diseases or respiratory problems should avoid physical exertion as much as possible.
In recent years, exhaust fumes from vehicles have aggravated the air pollution problem in the urban areas. There is increasing public demand for improvements in air quality. Apart from passing legislation and carrying out studies on how to reduce air pollution, the government should also educate the public about the problem. People are often not aware of the latent hazard to their health, as symptoms are not that noticeable at first. Studies and surveys conducted in other countries have clearly shown that long-term exposure to a polluted environment can harm our health. To protect public health, the government has passed the Air Pollution Control Ordinance, which regulates various sources of air pollution. In 1990, the government passed a law to minimise the sulphur content in industrial diesel fuel. This significantly and quickly reduced the amount of sulfur dioxide in the air. The major sources of air pollution in Hong Kong, such as power plants, cement factories, etc., are under strict regulatory control. These restrictions ensure that waste discharged conforms to the standards laid down by the EDP. There are also relevant laws to regulate dust stirred up by construction sites, as well as the exhaust oil fumes discharged from eateries. In the past, the fuel used in cars contained lead. Burning leaded fuel increases the suspended particulates in the air, which is hazardous to public health. Leaded fuel also damages the catalytic converters in more modern engines and increases the emission of exhaust fumes.
The government has phased in unleaded fuel since 1991 and from April 1, 1999 stopped the sale of leaded fuel.
The use of low-sulfur diesel fuel can reduce the emission of particles from diesel engines. With government encouragement, all local petrol stations now sell only low-sulfur diesel.
Low-sulfur diesel fuel contains less sulfur. Drivers say that it causes less pollution and that fewer black fumes are emitted.
The government also offers funding to support the installation of particle filters on all diesel vehicles that were manufactured in the European Union before 1995. This helps reduce suspended particulates. Regular inspection and maintenance is very important in minimising the emission of black fumes. Vehicles imported after 1995 have to comply with stricter fume emission standards laid down by the European Union. The standard used in Hong Kong now is the same as the EU one, which is the EU 3 standard. This is much stricter than the ones adopted by other Asian countries. Following this standard reduces exhaust fume emissions from vehicles.
Since January 1, 2001, all newly registered vehicles are required by the European Union to comply with the EU 3 fumes emission standard. This new standard is much stricter than the EU 2 standard passed in 1997. On average, vehicles within the new standard emit 30% less pollutants than those within the old standard.
Compared with diesel fuel, LPG combustion doesn't produce black fumes or particles. Other pollutants discharged are also relatively few. That's why, in the year 2000, the government allocated funds to sponsor taxi owners to switch from diesel fuel to LPG. And with effect from August 2001, all newly registered taxis are required to use LPG only. It is expected that by 2006, all diesel taxis will be phased out.
Of course, is much better. The engine's quieter and the air's fresher.
LPG taxis should be better.
More and more taxis have switched to LPG. The government has also exerted considerable effort to introduce other types of environmentally friendly vehicles that may ultimately replace diesel vehicles. It has completed another round of testing on alternative fuel for minibuses. Further study will be conducted on how to replace diesel minibuses. Outdoor air quality is important. But we should not neglect the problem of indoor air pollution. In an enclosed space lacking sufficient ventilation or fresh air, carbon dioxide and other pollutants accumulate. Excess carbon dioxide results in indoor air pollution. It also leads to breathing discomfort and fatigue. Certain construction materials, particularly mud, gravels or granite, release radon. Radon is radioactive and can cause diseases such as lung cancer. New fiberboard furniture often releases formaldehyde, which is volatile and carcinogenic. Enclosed space with poor ventilation and humid air is ideal for the growth of viruses and bacteria. Thus, they too may lead to indoor air pollution. To reduce indoor air pollution, the government has introduced the Smoking Public Health Ordinance, which regulates the designation of non-smoking areas and the placement of no smoking signs. Tobacco advertisements are banned on television and in print media. Such measures effectively reduce indoor air pollution by reducing passive smoke inhalation. Laws and regulations on the ventilation system in buildings and public premises are also set up to safeguard indoor ventilation. Labour laws ensure that employees can work in a safe and healthy environment. The EDP has also prepared a set of guidelines on how to improve air quality in offices, buildings, or public premises. These measures will give us all a chance to breathe fresh air.